Okay, today we're talking about writing inverse functions. And what an inverse function is that every function has something that would undo it. So an inverse, I mean, that's what the inverse does. It's the opposite, right? And what you'd have is you always have a function given, well, you don't always. You have most functions given by some sort of rule, and you use an input, which is the x, to give you an output. Well, what an inverse function does is it switches that and it takes the output and returns your original input. Let me show you what I mean by that. All right, so in this first example, we start with f of x right here. And this notation right here means f inverse of x. When I just have that exponent of a -1 above the f, it just means f inverse. Okay, so I start with f of x, and I want to evaluate that for x equals 5. So f of 5 is, I just plug that into the rule, 3 times 5 plus 1. 3 times 5 is 15, plus 1 is 16. So my input here was 5, and my output was 16. So what the inverse does is, if you use the output from the original function as your input on an inverse function, it should give you the back the original x value that you started with. So we show that by plugging in 16 to f inverse. 1/3 of 16 is just 16 over 3. Since they have a common denominator, you can just subtract the numerators and keep the denominator, and you end up with 15 over 3, and 15 over 3 is, of course, 5. So it's switched around here, but in this case, I do have 16, which was my old output, returning a value of 5, which was my old input. And that's what an inverse function does. So I think I will put this in the next video, but in the next video I'm going to show you how to check to see if two functions are inverses of one another using composition of functions.